width is delta V, that is equal to twice MP by L. So this Q is a random variable for a particular level. We are considering a particular level, and since this quantization error is equally likely, so we don't have to calculate it for every level. The same will be repeated for every level. So considering this as origin, this random variable range of this random variable will be from MP by L to minus MP by L. Right. So this is the range of this random variable, and outside of this range we will consider it as 0. And since the error is equally likely, so the corresponding probability will be like this. This value is L by 2 MP. So it is equal probable. So we can write the second moment of this Q, that is equal to integration minus MP by L to plus MP by L Q square PQQ dq, that is equal to PQQ is this. So if you calculate, we will get final expression is 1 by 3 MP square by L square. So the quantization noise can be written as 1 by 3 MP square by L square. Now the signal power can be written as m square t bar. So output SNR that can be written as 3L square m square t bar by MP square. So this is the expression of SNR for a PCM system. In digital system, this L is chosen in such a way that it is equal to 2 to the power n. N is another integer. Like for n equal to say 2, L will be equal to 2 to the power 2 equal to 4. That means this n signifies the number of bits to be transmitted for each sample. So if we allow 2 bits to transmit a particular sample, then the number of levels would be 4. Similarly, if n equal to 8, that means if we allow 8 bits to transfer a single sample, then L would be 256. So number of levels will be 256. Now M is band limited to say B hertz. That means minimum 2B samples, according to Nyquist theorem, minimum 2B samples are required. Per second to transmit this particular signal of bandwidth B hertz. So if we require to transmit 2B number of samples per second, and each sample is sent by n number of bits, so to transmit MT we require 2nB number of bits per second. So total number of bits is 2n into b. That means 2nB piece of information per second we have to transmit. So the bandwidth of PCM BT will be the half of the number of bits per second, that is n into B hertz. So this is the bandwidth of the PCM system. Now since L equal to 2 to the power n, so L square will be equal to 2 to the power 2n. Now consider this expression SNR is equal to 3 m square t by mp square into L square. So assume this one is constant of that particular system, so C into L square. Now L square is 2 to the power 2n, so C into 2 to the power 2n. So if you take the logarithm in dB, that is equal to C into 2 to the power 2n, that is equal to 10 log 10 C plus 10 log 10 2 to the power 2n. So assume this constant as say alpha, so alpha plus this to the power will come at this side, so it becomes 20 n log 2 to the base 10. Now log 2 to the base 10 is nearly equal to 0.3, so it turns out to alpha plus 6n in dB. So this is another way of expressing this SNR value, and the bandwidth is this. So let us try to understand with the help of a simple system. Suppose the value of n was 8, and the bandwidth of the signal is say 4 kilohertz. So the bandwidth of PCM will be 32 kilohertz, and corresponding SNR in decibel is alpha plus 6 into 8 dB. We are trying to understand the effect of n on bandwidth and SNR. Now let n equal to 9. So number of bits is increased just by 1. So what happens? BT is now 9 into 4. SNR equal to alpha plus 6 into 9. Right. So change in bandwidth is 4 kilohertz, and it is increased. Increase in SNR is 54 minus 48, 6 dB. So what is the percentage of increment of bandwidth? The percentage is of the order of 12%, 12 point something increment. So if we increase the value of n by 1, the change in bandwidth or increment in bandwidth is only 12% or 12.5%. What about SNR? 6 dB means 4 times. So SNR increment will be 4 times means 400%. So enormous increment in SNR, though the increment in bandwidth is very small. That means by changing this value of n, number of bits, we can achieve excessive amount of SNR improvement, whereas the corresponding change in or increment in bandwidth is very small. So this is one of the most important feature of this PCM system. Now we will consider the application area of PCM. Mainly it is used in telephony, and because of its excessive noise immunity, it is also useful for deep space communication. So these are few applications of PCM system. Now the advantage. Very high noise immunity. This is one of the feature advantage of PCM. Regenerative repeaters may be used. is another advantage. PCM signals may be stored easily. Storage is very easy. Various coding techniques may be used. So these are the advantages. There must be some drawbacks as well. The first drawback is encoding, decoding and quantizing circuit. Are very complex. And PCM requires large bandwidth. These are the disadvantages of PCM.